When you're coding a program, if you have information that you need to stick around between opening and closings of that program, so you run the program, do some stuff, close it down, if you want that information that you've created to be available the next time you open a program, then you're going to have to take that information and write it to the hard disk, which is something we haven't talked about yet. So I thought I would review the basics of writing to a file. The command we're going to use, you have to first input OS for one of the things that we're going to do. So this is some commands that help Python interact with the operating system. The basic command for opening a file in Python is to use a with, open, as, and then give the name. I generally use F, but you can use anything here for the file name that you want. So the open command has a few different parameters it takes. This is the name of the file, and this is the mode that you're going to open it in, and that's one of the things that we're going to cover in this video, but there's a number of different modes that we're not going to cover. You can read and write in binary mode. For example, if you were writing out video files or something like that, or image files like a JPEG, then you'd want to be in binary mode. And then the encoding, you're generally pretty safe in the UTF-8 encoding, so we'll specify that. So we're going to open this in W+, which means that we can read and write to this file. And if the file write.txt doesn't exist, if you open in W+ mode, then Python will go ahead and open it for you. There are other modes like, let's see, where is it? R, where you're just reading. If you open a file or try to open a file in R mode and the file doesn't exist, it'll just send you back an error. So the advantage to using this with open as F command is that you want to make sure that in the end, no matter what happens, that file gets closed. So if there are any other errors inside your program or that kind of thing, you have to make sure that file gets closed, because otherwise there's no guarantees as to what's going to happen with your information. If it doesn't get closed, the operating system could just leave it blank. So you can think of this with command is acting like the try, except, and finally commands we talked about in a previous video, where the finally gets executed no matter what. So with this with command, you can do a bunch of stuff inside of this, but no matter what happens, it's going to close this file for you in the end. Well, I mean, unless somebody hits your computer with a hammer in the middle of the with command, at that point, I think you're sort of out of luck. Okay, so what I'm going to do is open write.txt, and I'm going to just write a bunch of numbers in here. So I got two loops going. Range is 10, which means that the numbers are going to go from 0 to 9 in each case. And the command for writing to a file is pretty simple. Once you have the file name F, files have a method available to them. And so we're going to do f.write, and we're just going to take the sum of these two integers, I and j, and we're going to write them out to the file. I'm also going to print it to show you a difference between writing to the file and not writing to the file. And then every time this loop is done executing, I'm going to write out a new line character. Now I'm doing something interesting down here. I'm flushing the file, and then I'm calling the OS and asking it to sync the same file. In this case, I have to call it with a file number. Now, the reason why I'm doing that is because traditionally, writing and reading from a file are expensive in terms of the amount of processing time it takes. So those are buffered operations. So when you write to a file, it doesn't immediately go to the file. It actually goes to a buffer. Now, it turns out that that's actually buffered in many different ways. So Python can buffer that. And what it means by buffering is instead of actually writing it to the file, anything that you write actually goes to a chunk of memory, and until that chunk of memory gets filled up, it can just sit there waiting for Python to decide it has time to actually write to the file. So when you do a flush, that flushes the stuff out of Python's memory and then flushes it to the OS. But the problem is the OS is also buffered. So this, when you do a read and write to a file, ultimately it's the operating system that's responsible for doing those reads and writes. So The OS does the same thing. It actually buffers it. So the operating system, Windows in this case, could be Ubuntu, whatever, will buffer that, set up aside a chunk of memory and RAM, and wait until it has time to actually write to the hard disk. So it keeps track of all these buffers, and everything works along just fine unless the computer happens to crash. If the computer happens to crash while you have stuff sitting in RAM, well, when the computer reboots, it's gone. So what we're doing is asking with os.fsync, we're asking the operating system to also flush its buffers out and actually write this thing to the hard drive. At that point, you think, well, okay, so that's very secure. I've asked Python to flush its buffers. I've asked the operating system to flush its buffers. So now, at the end of this, I have definitely written to the file. Well, not quite. It turns out that hard disks, in order to be faster and try to keep up with modern requirements like playing video games, which are very taxing, have their own buffers. So hard disks have a built-in RAM, a buffer. We don't have a command to flush that buffer. So we do our best to get this thing to actually write to the hard drive, but it turns out it's a little bit complicated. So you'll see why I'm trying to do this here in a minute, because I want to show you something. Ultimately, what this is all for is I want to show you something that happens with this W+. When you write to a file, because I'm going to do this twice. So I'm going to write out these lines, and then I'm going to pause for a second, and I have to pause because this is not going to be immediate, or, well, it may or may not happen to us. It seems like immediate. It depends on what kind of mood the hard disk is in and the operating system is in, and so sometimes this happens immediately, and, well, sometimes it doesn't. But what I want to do is show you is what happens when I write to this file and then open it again in W+ mode. And this time I'm going to change just slightly. It's the same basic code except for having a plus sign, I have a minus sign here. We're going to do the same thing, write a bunch of stuff out to the file, try to flush it in so it gets written. And then when we're all done, this is actually a nice little piece of code to show you how to read in a file. So I open the file, I'm again opening it in W+ mode, and then to actually read stuff in the file, it's very simple. A file is iterable, so it has an iterator, and you just do for-line in F, and it just reads in a line, and then we're going to print the line out. All right, so let's see what happens when we run this thing. So we're going to run write mode. And so it's printing out, because I've got that print command up there. So the first time through this loop, it's printing out 0 through 9. Then I goes to 1. And now we're printing out 1 through 10. Then I goes to 2. We go 2 through 11, and so on, until we get down to where I is 9, and then we go 9 to 18. And so all those things should have been written out to write.txt at this point. So we hope, well, we don't have anything right now, do we? Okay, so we don't have anything in write.txt. I need to get this thing to refresh somehow, and I'm not seeing it, so I discovered a little trick. I'm going to go over here to File Explorer, and there's write.txt. I know what directory it's in. I'm going to click on that. So here's those numbers written out to the file write.txt. Notice that in Python, when you do this write, unlike a print statement, so we did a print here, and for each time we do a print, we get a new line, but with write, you don't. So we had to actually insert that new line symbol every time the inner loop, the J loop, was done executing. So here we get the 0 through 9, and 1 through 10, 2 through 11, and so on, down to the 9 through 18. So each one of these rows represents this inner loop going through its thing and printing out 9 numbers. All right. So now we should have this here. So now we have this here. Because I've opened this up in File Explorer, it forces PyCharm to update this. So here's what the file looks like now. All right, so now I'm going to hit Enter here, which is going to unpause this and send us into this next loop. And what I want to do is show you what happens with this W+ mode when you do this. So what it's going to do is at the end of this with open statement, Python closed that file write.txt. And you always want to use a text file when you're reading and writing in this UTF-8 mode. In binary, you could use different file names, but we're going to do it with text files. Okay, so when you do a second with open, it's opening the file again, and when it does, it starts the file at the beginning of the file, not where you left off, but at the beginning, and gets rid of anything that was in there. So we have to be careful about this. All right, so I'm going to unpause this and rerun this. Now we're down here at pause 2. And let's see if it flushed this. It didn't. All right, so I'm going to go back over here and reopen this. And now notice, remember I had a subtraction, so this is 0, -1, out to -9, and so on. So it's completely rewritten this file, and the information that we had in there before is gone. And let's see if it's updated. Okay, so now it's updated over here. Now I'm going to unpause again at the second pause, and we're going to open this file again and try to read a bunch of stuff in. So what do you think is going to happen? So right now we have all this information in here, but when I open this again in W+ mode, what's it going to do? Well, I got to reopen it. There's nothing in there. And it's because in the very last set of statements here, we did a with open in W+ mode. That reopens the file, and basically think of it as erasing what's in there and start you back at the beginning. So you're expected to reproduce whatever is in there if you want to keep it. Okay, so there's a way around this. If you don't want to erase your file every time you open it, if you just want to open and read some stuff in, you can use read mode. This is essentially the exact same set of code that we had over here. I took out the middle pause, so we're not going to write out twice. We're just going to do the first bit of writing out to read mode.txt with the plus sign. Flush everything out. Pause, and in this case we're going to read stuff in, but when we open the file we're going to open it in a read mode. And when we do that, it's not going to erase the file. It's going to leave the file as we last left it and just allow us to read things in. So there's two things to be gained from here. If you want to read in from a file, you probably want to open it in read mode, and again, reading in a file in Python is very simple. It's a very simple little for loop to do that. All right, so let's run this. So we're going to run it. We'll go up to the first pause. And at this point, I want to make sure that this file has the right stuff in it. So we'll open it up here. Okay, so this looks like it should, as we'd expect it to after those two for loops have executed. And now, after pause 1, oh, I ran the wrong thing, didn't I? Brilliant. I'm actually running write mode. Oh boy. Let's try this again. We'll run read mode this time. So now we're at the pause. I should have noticed that before. And let's just double check read mode again. So it looks like it should at this point. So we'll go through the pause now and go into these reads. And so notice that after we've done this open, read mode still contains the information that it had before. Also notice that with these prints, we're getting an extra blank line in here, and that's because each one of these lines in this file has an end of line character on it. There's something else you may notice. If you were actually writing these integers out to a file, you might want to space them out or something, because once you read these in, it would be pretty hard to tell what that number is. Did we really mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or did we mean something else? Is that a 1 and a 0 on the end of that, or a 10? But that's a different matter. Okay, one last thing. What if you wanted to add something to the end of the file? So over here, We wrote out a bunch of things where we added numbers together and we got this kind of output. Then we subtracted some numbers and got a different output. And in this case, we overwrote what was in here. But what if we wanted to add that on? Okay, well, there's an append mode. So this is almost exactly the same code as the code we first looked at, except for the difference is here we're using append mode on the second open when we do the subtraction. And in the end, we're going to do a read mode. Okay, so notice the difference what happens when we use append mode and read mode. And we're going to run this. I'll run the right file this time. Okay, so run append mode. We're at pause 1, so now let's go look at append.txt and see what that looks like. So this looks like what we would expect. And now what we're hoping to do is add on to the end of this file all that information, but we'll redo the subtraction instead. So we're going to go through pause 1. And we'll go take a look at this again. Let's close this out and reopen. And now we see that that information has been tacked on the end. Append mode makes sense, right? And now, when we open the file for the third time to actually read it, and if you did this, if you had these separate opens, this would actually force all the flushes. The operating system and the hard disk and everything is smart enough to know that if you've reopened that file, it needs to update things. So this actually will force the flush, all of the flushes to happen, and all the buffers will be cleared. Anyways, this should then print out all the results. Okay, so the emphasis here in this lesson was a couple of things. Opening a file, you want to use the with open command. That guarantees that your file will be handled appropriately. It's really just like doing a try except finally block, but this is a lot easier and simpler to read. Be aware of the different modes for opening a file. There's a write mode. W+ actually creates the file if it needs to be. Append mode and a read mode. And then finally, if you are trying to read in a file, it's very simple to do. You just do a 4-line inf and then print line, and that is it. If you want to get rid of those new line characters at the end, it's actually pretty simple to do. You can do what's called a write strip and strip off the new line stuff like that. Hopefully that should do the trick. Let's run this again. Yeah, so you can just strip off those new line characters at the end of each line in your file, just doing an R strip, and then we don't get the extra blanks when we do the prints. Anyways, again, the emphasis here was using the with open command for files. The flushing stuff, for the most part, you wouldn't really have to worry about. I was doing that, trying to get this video to work and actually make sure things got written out to the disk at an appropriate time. Modes and simple for loops to read in a file.